So here's another example. So we want to test the summation from n goes from 1 to infinity of 1 over n squared plus 1 for convergence or divergence. So one of the things to kind of look at is that the test of divergence isn't going to help us here because you'll immediately see that the limit as n goes to infinity will just be 0. So instead, probably the integral test here would probably be something that you might want to consider. So using integral test. What you want to be able to do, you want to find the integral from 1 to infinity of 1 over x squared plus 1 dx. Okay, so if you look at this integral, well, let's first start off with the infinity sign. So let's just take the limit as b goes to infinity from 1 to b of 1 over x squared plus 1 dx. Now what you want to look at is, okay, what is going to be the antiderivative of this guy? Well, if you look at this is just going to be arctangent. So it's going to be the limit as b goes to infinity, of tangent inverse of x. This is between 1 to b. So I'm going to have the limit as b goes to infinity of tangent inverse of b minus tangent inverse of 1. Okay? So then you want to be able to simplify this a little bit more. Limit as b goes to infinity, tangent inverse of b. And then tangent inverse of 1 is going to be equal to pi over 4. Okay. Now all we have to figure out is what's going to happen when b gets really, really large in this arctangent. So if you remember what arctangent kind of looks like, it kind of looks like this. So here's pi over 2. Okay, you have these horizontal asymptotes. And then the inverse tangent looks like this. Not the tangent, but the inverse tangent kind of looks like this. So you can see that as b gets larger and larger, this starts to go into the top asymptote, which is going to be pi over 2. So this limit guy right here is going to be pi over 2 minus pi over 4, which is going to give us pi over 4. Okay, so based on the integral test, we saw that the improper integral 1 to infinity of 1 over x squared plus 1 dx converges. So, by integral test, the sum from n goes from 1 to infinity of 1 over n squared plus 1 also converges. Okay, so that's what we can claim. All right, so another way that you can do it, you can also do other different things to do problems like this, but technically the integral test is really useful. However, it is really computationally expensive because you do have to think about maybe if you were looking at problems that look like this, okay? So if you have something that look like this, you might have to consider doing U substitution or maybe integration by parts. So it can be really difficult sometimes. So you might want to kind of think about the integral test as one of the last resorts. Use it unless you really need to. And obviously, you need to make sure that these summation, these series are also decreasing. Okay? So now, the last thing to really kind of talk about is just p-series. Okay, so you can think of this as another test. Okay, now what p-series says is the following. So if k is greater than 0, then the summation from n equals k all the way to infinity of 1 over n to the power of p converges if p is greater than 1 and diverges if p is less than or equal to 1. Okay? So this is actually a very powerful test because if I know that something is a series is of this form, all I really have to look at is just the exponent. That's all I have to look at. And if this exponent is greater than 1, it's going to be convergent. And if it's less than or equal to 1, it's going to be divergent. Okay? Simple as that. Okay? So instead of trying to do The integral test, this is all it is. And you can actually try to prove it to yourself. Just take the integral of 1 over n to the p power, and you'll be able to see when it converges and when it diverges. Okay, so here's an example. Determine if the series converge or diverge. Okay, so what's going to happen? So let's say you have the sum from n equals 4 to infinity of 1 over n to the power of 7. Okay, well, all we have to do is that this is actually a p series. Okay, here p is equal to 7. 7 is the number that's greater than 1. Because 7 is greater than 1, by p series, the sum from n goes to 4 to infinity of 1 over n to the 7th power converges. And that's it. So this actually is substantially much faster, and it makes it the tests a lot easier to do instead of doing the whole integral. Okay, so that just immediately tells us that it's going to converge. Okay, what about this one? The sum from n goes from 1 to infinity of 1 over square root of n. Well, here we can write it as the sum from n goes from 1 to infinity of 1 over n to the 1/2. P in this case is equal to 1/2, which is less than 1. Okay, when P is less than 1, what is it going to do? Diverge. So what are we going to say? By P series, the sum from n goes from 1 to infinity of 1 over square root of n diverges. Okay, and that's all there is to it. So what you really want to be able to look at, you want to look at the value of p. That's usually going to be the exponent on the denominator, and then just figure out if this is going to converge or diverge. Okay, so a p series, super simple, not too terrible at all. It's one of the more easier ways to identify whether a series is going to converge or not. Again, a lot of the problems, we don't know what the actual sum is. We use computer software to kind of try to figure it out, but at least we have an idea of whether it's going to get to a number or it's just going to go increasingly large. Okay.